Okay, so this video is to review for the free response section of the final exam for Math 2B. So this looks very similar to what the final exam will look like. So as I go through it, if you try and pay close attention and follow my logic, it should help you immensely with your final exam. So the first couple questions are asking us to solve systems of equations for x and y. So the key thing when I'm given a problem like this is to notice that y is equal to this and y is equal to this. So if they're both equal to y, each of these equations, or expressions I should say, have to be equal to each other. So I can set x squared plus 4x plus 16 equal to 12x. And then I'm going to go ahead and get everything on the same side of the equal sign so that I can factor to solve for x. So I have x squared, 4x minus 12x is minus 8x plus 16 is equal to 0. So now in order to factor this, I need two numbers that multiply to 16, because my a times c is 16, and my b is a negative 8. So it needs to multiply to negative 16, add to 8, negative 8. So that would be x minus 4 times x minus 4, because negative 4 times negative 4 is 16, negative 4 plus negative 4 is negative 8. So if I set x minus 4 equal to 0 and add 4 to both sides, x is equal to 4. And in this case, I only have one value for x because both of these would give me my same answer. Oftentimes when solving problems like this, we would have two values for x and two values for y. And once I've found x, it's pretty simple to find y because I can just plug the 4 in. So 12 times 4 is 48, so y is equal to 48. I'll go through number 2 with you also, but I'm going to go a little bit faster now that I've explained what it is that I'm doing. So I'm setting these equal to each other and then getting everything on the same side. So I have x squared plus 9x plus 10 equals 0. So let me see. Oh, I just did my addition backwards. I'm so sorry. 6 plus 4 is 10. So this is plus 10x. And 4 plus 5 is 9. That's going to make our factoring a lot easier. So my a times c is 9, my b is 10. So two numbers that multiply to 9 and add to 10 are 9 and 1. So this factors to x plus 9 times x plus 1. And if I set each of those equal to 0, I'll get x equals negative 9 and negative 1. So those are my two x values, which means I have to plug in both x values to find my y values. So I'll start with negative 9. Negative 4 times a negative 9 is a positive 36. 36 minus 5 is 31, so y equals 31. And if I plug a negative 1 in, negative 4 times negative 1 is 4. 4 minus 5 is a negative 1. So y equals 31 and negative 1. So those are just a couple of examples of solving systems of equations. Numbers 3 and 4 deal with writing expressions in words and expressions that are already in words as mathematical expressions. So we're starting with writing the following phrase, the sum of 2 times a number x and 5. So if I start at the very beginning, the sum, well, I know that is addition, so I know I'm going to have addition in here. And it's the sum of this and this. So on this side of my equal sign was just going to be 5. That part's easy. Then I have 2 times a number x. Well, 2 times x I can just write like this. So this phrase can be written as 2x plus 5. So then I'm going to do that backwards to write the expression for number 4. So I have this minus right here, and the word for minus is difference. So I know I'm going to start with the difference, and then of my first part, so difference of 4, and the quotient, this dividing line is quotient, of 3 and x. Perfect. So 5 and 6, we now have a couple of story problems to solve, and I can already see a typo in here that I'm going to fix. So we have Annalise, who's measuring the progress of her plant's growth. Today, the plant is 7 centimeters high, so it's starting at 7 centimeters, and then it grows 1.5 centimeters per day. So I'm going to say that X stands for how many days there are. So 7 plus 1.5 times however many days there are. How many days will it take for Annalise's plant to be 22 centimeters long? So how many days till this equals 22? Well, once I have my equation, I can go ahead and solve it. So I have 1.5x equals 22 minus 7, which is 15. So then if I divide 15 by 1.5 on both sides, oops, x is equal to 10. So it will take 10 days for Annalise's plant to be 22 centimeters tall. Number 6, McCall is planting a garden with the length 3 more than the width. What is the length and width of the garden if the area of the garden is 70 feet squared? So I know that my length is 3 more than my width, so that would be W plus 3. And then I also know that area is equal to length times width, so if my length is W plus 3, I'm going to multiply that times W, and that equals my area, which is 70. So I can go ahead and solve this. So W times W is W squared. 3 times W is 3W equals 70. And now this is looking like something I could factor, so I'm going to go ahead and subtract 70 from both sides. And I have W squared plus 3W minus 70 equals 0. So if I factor this, I can solve for W. So my A times C is a negative 70, and my B is 3. So two numbers that multiply to negative 70 and add to 3 would be negative 10, positive 10, and a negative 7. Because 10 plus a negative 7 is 3, 10 times a negative 7 is negative 70. Meaning that this factors to W plus 10 and W minus 7, and if I set each of those to 0, W equals negative 10 and a positive 7. So if I think about this, McCall's planting this garden, and it can't have a width of negative 10 and 7, it can only have one width. But if we think through this logically, a width of negative 10 feet, that doesn't really make any sense. So the width has to be 7 feet. So my width is 7. But this asks for the length and the width. Well, I already know my length is 3 more than the width, or 3 plus the width. So 7 plus 3 is 10. So my width is 7 and my length is 10, which totally makes sense because my area is 70 feet. 7 times 10 is 70. So now we're going to move on. That was our very first unit from the trimester. We're going to move on to probability. So we've been given some sets, and now it wants us to find some various things in regards to them. So the first is A union B, which what is in A or in B? So this is literally everything in A and everything in B, because if it's in A, we're going to include it, or if it's in B, we're going to include it. So I'm going to include everything in A to start, which is 1, 2, 3, and 4. And then I already have 3 and 4 from B, but I don't have the 5, so I'm also going to include the 5. Versus number 8 is what is in A and in B. It's the intersection of A and B. And this is only the numbers that are in A and they're in B. So like 1 is in A, but it's not in B. 2 is in A, but it's not in B. 3 is in A and B. 4 is in A and B. 5 is in B, but not in A. So the only two numbers that are in A and B are 3 and 4. Number 9 is A a subset of C? What that question's asking is everything that's in A also in C? So if I look up here, all these numbers in A, well, the 2 and 3 are in C, but the 1 and 4 are not. So A is not a subset of A. A is not a subset of C. B asks, is C a subset of A? Well, if I look at C, I have 2 and 3, and 2 and 3 are also in A, so I could say yes, C is a subset of A. The last one for this section is what is a complement, which means what is not in A. So my sample space is the numbers 1, 2, 3, 4, 5, 6, and A has 1, 2, 3, and 4. So the only two numbers A does not have are 5 and 6. The next section is still in probability, but now we're finding the probability from a frequency table. So it says that a survey is conducted to see if people think football and soccer are awesome, yes or no. So we're going to use this table to answer our questions. So the first is what is the probability of people voting soccer or yes? So this would be a union, soccer or yes. So I've got to include everyone who says soccer, which is 270, plus all the yeses, which is 290. But I have to make sure I don't include anything more than once. So if we look, I just included all the soccer and all the yeses, which includes this 231 twice. I included it in soccer and in yes. So I'm going to subtract that 231, and then I can divide it by my total of 650. So I'm going to go ahead and do 270 plus 290, subtract 231, and that's going to equal 321 over 650. And once, 329 over 650. And 329 divided by 650 comes out to be about 51%. The second question is the probability of football and no. So we're only going to look at people who are in the football column and in the no column, which is just these people. So football and no is 321 out of 650, which if I do that dividing, I come out with about 49%. 13 is the probability of yes. So how many people are in the yes row? 290. So I'm going to do 290 divided by 650, which comes out to be about 45%. And then the last one for this section has this little line here, which means given. So the probability of no given soccer. So that given part, that second part is really important because it means we know they're in the soccer column. So this is the only column we care about. We don't care about the rest because we know that the soccer part is true for this person. So we want the probability of them saying no, given they were asked if soccer is awesome. So if soccer is awesome, did they say yes or no? We want to know the probability they said no. Well, 39 people said no out of 270 people that voted on soccer. So I can do 39 divided by 270, which comes out to be 14%.